example for decision tree. We need to see some concrete example to understand the whole concept well. Yeah. So let's do it in this video. So before we do it, so let's look at a typical comparison-based decision. How do we represent a comparison-based decision? Very simple. Yeah. We assume each decision has two possible outcomes. Yeah. So if we compare A and B, we write in this way, A colon B, just a simple way. Okay. Although you can write different way. Right? Yeah. Here, let's use A colon B represent. We compare A and B. Yeah. The first outcome, A less than or equal to B. Yeah. So we put equal and less than together, combine. Yeah. Then we just have two outcomes, right? Otherwise, if A less than B, A equal to B, A greater than, three different outcomes. So then it is not very convenient. Okay? Yeah. So here, two outcomes. All right. Then for sorting, yeah, sorting fits this model well. Yeah. Because when we do sorting, every comparison, we will have two possible outcomes. Okay? Yeah. So then we can draw decision tree with this assumption. Yeah. All right. Before we move to the concrete example, let's look at the summary. Yeah. Understand decision tree. Yeah. The last time. Yeah. Before we work on an example. First, definition a little bit. Yeah. A decision tree is a full binary tree that represents comparisons between elements that are performed by a particular algorithm on an input. Yeah. But here, as I mentioned in the previous video, the full binary tree, sometimes we may need to modify a little bit. Otherwise, if our algorithm does not fit this model, then we cannot use decision tree, right? Yeah. But sometimes we want to use decision tree. Yeah. Yeah. So that's one special point. Yeah. But this definition is, standard for the current textbooks. Yeah, all use this definition. Yeah. But it does not mean we cannot modify in our real world applications. Yeah. So we can do modifications. Yeah. The goal is to solve a problem in the right way. All right. Yeah. Decision trees can be applied on search, sort, selection, etc. Yeah. But search is very special. When you apply on the search, yeah, probably selection, yeah, because the selection, could be different. But on sort, we always have two outcomes. Yeah. So that fit the model well. But for search, so definitely sometimes not. But for selection, there is a possibility. Yeah. So I need to take a look at the selection case. Yeah. All right. Any comparison-based algorithm with two outcomes for each comparison has a decision tree representation. How about one outcome? Right? How about one outcome case? Do we eliminate one outcome situation? Yeah. So that's a big question mark. Yeah. Big question mark. Yeah. All right. We can use the decision trees to study comparison-based algorithms, including those unknown. Yeah. For sorting algorithms. Sometimes, for example, in order to estimate the worst case efficiency. We cannot exhaust all the possible sorting algorithms. In that situation, we can use decision trees to study those unknown sorting algorithms. If we have some time, I will talk about that. Okay? If I can find a little bit time, I will talk about that special case. All right. Next, let me run that example. Sort 3 elements. It's a simple example, but we want to see how to draw a decision tree for this algorithm. All right, so when we start, we have 3 elements, A, B, C. First, at the root of the decision tree, we compare A and B. So A colon B, that is our root node. All right. Then, 2 possibilities, A less than or equal to B and A greater than B. So then we have 2 branches from the root. For the first branch, next decision, compare B and C. If you want to put A and C, it's okay, right? But here we just make one special choice. B colon C, 2 possibilities. B less than or equal to C and then B greater than C. But for the B less than or equal to C, we have enough information to draw the conclusion. So we get a sorting result. So we reach the leaf node. That is the sorting result. A less than or equal to B and less than or equal to C. The first leaf. Then for B greater than C, the other branch, we do not have enough information. So we need to compare A and C the last time. 2 possibilities. The first one, we have this sorting result. The second one, we have another sorting result. Okay. Similarly, we can do the right subtree for A greater than B. So this time we compare A and C, 2 possibilities. For A less than or equal to C, we have enough information for the sorting result. So we reach the leaf node. For the second case, we need another comparison, B and C, and 2 possibilities. The first one, we get one sorting result. Second one, we get another sorting result. So that's the whole decision tree for this simple sorting algorithm. That's the whole picture. So this example, so you can see what is a basic decision tree looks like. All right. So that's the preparation. Next, we will use this decision tree concept to represent our binary exponentiation algorithm. All right, so let's finish this